Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the idea of correlation, and it is basically a measure to determine the strength and direction of a linear relationship. So here the key point is it is a linear relationship, and you want to see how strong it is and what is the direction. So there are different types of correlation coefficient. For example, there are also Spearman's correlation, and this is an example that is used in the categorical data analysis. But here, when we have a continuous data, you will be using the Pearson's correlation, and this is our focus here, which is the Pearson's correlation. Now, these are the notation that are used. When you see R here represents the sample correlation coefficient, and rho here represents the population correlation coefficient. So in other words, R here is the statistic, and rho here is the parameter. Now, the range of a correlation coefficient is between -1 and +1. So this is the values of the correlation coefficient that you should get in order to make sure that your calculation is correct. So the value has to be between -1 and +1. And the way you can obtain the correlation coefficient is by implementing this formula here. It looks complicated, but as you can see later on, it is not so much. And you can see that this part here is the numerator, and at the bottom part here is the square root of these two terms here that are multiplied with each other. Okay, now the value of correlation R will tell you whether the relationship is positive or whether the relationship is negative. Well, that depends on whether you get a positive sign or a negative sign, and the strength of the relationship, whether it is strong linear or weak linear. So basically, if you get value around 0 or close to 0, that means no linear relationship. If you get close to -1, that means it is a strong negative, and values close to +1 means it is a strong positive relationship. So here we've got strong linear, somewhere here will be weak linear, and close to 0 is going to be no linear relationship. Okay, so now based on the same data which we have seen in example 6.1, let us try to obtain the Pearson's correlation. Right, so the formula that we need to use is this one here, and you will see that for this one, this n here is the sample size. So sample size is 6, and in order to obtain this one here, this is the sum of xi multiplied with yi. That means you need to multiply x and y together. Okay, so first what you need to do is you need to find the results of multiplying x and y together. Okay, so this is what we have to do first. So let us create a column for that. So that is x and y together. 43 times 128, this is what you get, and so on. 70 times 152, this is what you get. So that is the process of getting the values of xi multiplied with yi. Okay, so this one is well, we don't need this one yet. Okay, so how about this one? So for this one here is the process of squaring each value of x. So each value of x has to be squared first. So this is what we're going to do next. We get the value of x squared. So all the x here have to be squared, and the results are given on this column here. Okay, next this one here, this is something new as well. What you need to do is you need to square all the values of y. So that's what we're going to do next. We're going to construct another column that contains the squared values of y. So here 128 squared, 120 squared, and so on. So now what we need to do next is we need to sum up all the values in the respective columns. So you get all the values here, but you can see that this one is the value of the sum of xi, yi, which is this one. So that one is for this one, the sum of xi and yi. This one is the sum of xi is this one. The sum for yi is this one. The sum of xi squared is this one. This one is the sum of xi and you square it, so the sum of xi is this one and you square it. For this one is the sum of yi squared, this one. And finally, this is just the sum of yi and you square it. So the sum of this and you square it. Okay, so that's what it is all about. And let us just try and do it properly. So here we have r is equal to, let me just erase this part so that you can see it more clearly. Okay, so let us do this together now. R is equal to n. So n here is 6. So this one, sum of xi, yi is this one here. So 47,634 minus, this is sum of xi, which is this one, which is 345. And the next one is sum of yi. Sum of yi is this one, which is times 819 here, over the square root of. Now for the first term here, we have n is 6. This one is sum of xi squared. So xi squared, this one, so sum of it is 20.399. So I'm just going to write down 2399 minus, this one is sum of xi. Sum of xi is this one and you square it, so 345 square it. So that's the first term. And the first term here is multiplied with the second term. I don't have enough space. So let's just make it slightly big. So the first term here is going to be multiplied with the second term here. So this second term here is n. N is 6 times with the summation of yi squared. So this is y squared. So the sum of that is this one, which is 112,443. Now minus, this one is, this one is sum of yi. So sum of yi is this one and you square it. So 819 and you square it. Okay, so here you will get, for the numerator part, the value is going to be 3249. And the bottom part here will be the values of 3369 times 3897. And you will see that your final answer is going to be 0.8967. So that is the correlation coefficient for this data set. Okay. Alright, I think that's all for now. Thank you very much for watching.